Alright, so we're going to be going through a tract that comes into the cerebellum, all the steps that it takes, what peduncle goes through, the deep cerebellar nuclei, the neurotransmitters it uses, where it stops in the cerebellar cortex, where it ends up finishing, the kind of fibers it uses. We're going to be looking at a posterior spinocerebellar, which for our purposes has the same tract as a cuneocerebellar tract. The anterior spinocerebellar tract is very similar, with the only difference being which peduncle it goes into. Everything else about the tracts, I believe, is the same. So, posterior spinocerebellar and cuneospinocerebellar, classified as Mossy fibers. We know that from our notes on page 112. So they start down here, somewhere in the cord. They go through the inferior cerebellar peduncle. And now we continue up here to the spinocerebellum. And we know that it goes to the spinocerebellum because of the chart, I believe on page 109, I believe, we've got these three functional subdivisions of the cerebellum. The spinocerebellum, vestibulocerebellum, cerebrocerebellum. They all have input from different parts. Vestibulocerebellum is this little area right here. Spinocerebellum, roughly this top half. And the cerebrocerebellum, roughly this bottom half. We know, because of that little chart, the spinocerebellum has input coming in from the posterior spinocerebellar, the cuneocerebellar, and the anterior spinocerebellar. Now what we also know is because these are considered Mossy fibers, we'll write that down here, Mossy fibers, they come up into the cortex, and we'll zoom into here. We'll zoom into that little spot so that's easier to see. We're going to see that there's actually 3 layers there. So we'll draw our 3 layers. And this is the 3 layers of the cerebellar cortex, the outer part of the cerebellum made of gray matter. The inner layer we know to be the granular layer. The middle we know as the Purkinje, and the top as the molecular layer. Now we've got this spinocerebellar or cuneocerebellar fiber coming in, the Mossy fiber. And how do we know that it synapses on the granular layer? Well, because it's moss. Moss grows on the ground just the same as granules of sand, granules of wheat, granules of anything are going to be in the ground because they're small and they fall. Therefore, we know that the Mossy fiber meets the granular cells in the lower layer, right where it should. Now that granular cell, once it's met, it comes up to the top because it's had enough of being in the bottom. And it's going to meet up with a Purkinje cell, but not just any Purkinje cell, a spined Purkinje cell. And we know that because granules, I always think of little wheat or barley granules, a little bit pointed at the ends here. They almost look like they got little spines at the 2 ends. So it makes sense to me that granular cells meet up with the spine Purkinje fibers because these little granules also have spines on them. So that's how I remember which layers they go into. The spine Purkinje fibers then, from there, first, I should have mentioned this before, the granular cells at this little synapse here, they use the neurotransmitter glutamate. And I only remember that because of the opposite of aspartate, which we'll deal with when we talk about climbing fibers. But for now, glutamate is what the spine Purkinje fibers are activated by or stimulated by from the granular fibers. Back to these spine Purkinje fibers, they go from this outer layer, this molecular layer of the cerebral cortex, and they come down. So what we have here, if we go back to our big drawing, got our little granular cell, we got our spine Purkinje coming down. Now from here, the spinocerebellum, if you go to your notes on page 113, you'll see that they have three options when spine Purkinje cells come from the spinocerebellum. They can either go to the fastigial deep cerebellar nucleus, the globose, or the emboliform. That's just the rules. That's just where the notes say they go. Now they release, there's a neurotransmitter there that is used for these three synapses, 1, 2, 3. That neurotransmitter is GABA. It has an inhibitory effect at those three. Now there's a few more options here. The fastigial will tend to send axons out through the inferior peduncle, and it has a couple options. It'll go to the vestibular nucleus, it'll head to the reticular formation, which is easiest for me to remember because of that reticular cell, reticular formation, easiest to have a picture of in your head. The other place it'll go to is the nucleus. It's not drawn in here, but it's easiest for me to see. A nucleus, or nuclei, of cranial nerve 3, 4, and 6. That's where the fastigial deep cerebellar nuclei will send its axons through this inferior peduncle. Remember, those are coming from the spine Purkinje fibers from the molecular layer of the cerebellar cortex. Now, because they're similar, we're just going to use a different shade of blue. Anything coming from the emboliform or the globose can be treated as one. So that's what we're going to do. We're going to treat them as one. They go out the superior cerebellar peduncle. They've got a couple options as well. They'll hit the reticular formation, or they'll go up and they'll hit the red nucleus. And that, again, is on page 114. It's a lot of information that's got to be connected together from pages roughly 108 through 114 or 113. But that is one tract, or that's one pathway, starting with these mossy fibers from the posterior spinocerebellum and the cuneocerebellum that come up, inferior peduncle, up to the spinocerebellum, synapse on granular cell, comes up, granular cell uses glutamate to synapse on the spine Purkinje. Spine Purkinje comes down, has a couple options, either the fastigial nuclei, the globose, the emboliform. Anything from the fastigial will head down through the inferior, has a couple options, either the vestibulo, the reticular, or the nuclei of cranial nerves 3, 4, and 6. Globose and emboliform have a couple options. They act as one. They go through the superior cerebellar peduncle down to either the reticular formation or the red nucleus. And that is all one tract. I think that covers just about everything.